All right, let's begin with the class. Our objective is explanation of probability in today's class. So let's begin. Probability is not entirely new for us because we have already covered this topic in IGCSE and O-level mathematics, right? And we have a bit of foundations of probability as to what probability is. So first, let's recall that probability concept and then move forward towards the main thing that is there in S1 syllabus, right? So let's discuss probability first. Probability is uh, the chances or occurrence of an event. What are the chances of occurrence of an event? Is referred to as probability. Likelihood or chances of occurrence of an event. Like if, let's suppose if someone is saying that might be it rains today. Acha, probability is always for future events. Always remember, something that has not yet occurred, something that is to be done in future. We are predicting future. Let's suppose if you are talking about tomorrow and there are expectations that it might rain or it might not rain today. Someone asks us, what do you think are the chances of raining tomorrow? Then you will be saying that there are 70% chances. So this 70% when converted into a decimal value will give us probability. 70% means 70 upon 100, which actually means 0.7. So 0.7 was the probability, like is the probability of future event. So 0.7 probability of raining. So if someone says that if the probability of raining is 0.7, what is the probability that it does not rain? So I will say the total probability is 1, and if I subtract the probability of raining from 1, I will get the probability of not raining. So here comes the relationship that if we are talking about a particular event and its complement, what is the meaning of a complement over here? We have also studied sets. So this event A, right? Event A occurring. A would mean that event A occurring, probability of event A, and A not. A complement would mean event A not occurring. So if someone is saying that probability of R is 0.7, probability of R complement is to be found, what we will be doing, we will subtract the probability of raining from 1 to get the probability of not raining. This is same as 70% chances of raining. So if someone says what are the chances of not raining, you will say the total chances are 100%. You'll subtract 70% and you will get 30%. So if the chances of raining are 70%, the chances of not raining will then be 30%. So in percentage, the total percentage is 100%. In probability, the total probability, the maximum probability is always 1. So this is the fact that I have written. The probability will always lie between 0 and 1. The least probability can be 0 and the greatest probability can be 1. And the sum of all the probabilities will always equal to 1. This is also another important thing. Sum of all probabilities will equal 1. Right? And the probability of event A occurring plus probability of event A not occurring will also be equals to 1. So if we have to find the probability of event A not occurring, we will subtract the probability of event A occurring from 1. This is already explained. Now, how can a probability be found? So a formula is being told that if we are to find the probability of an event, PE means probability of a particular event. So if we have to find the probability of a particular event, then the number of outcomes in that event will be divided by the total possible outcomes. The number of outcomes in an event divided by the total number of outcomes. So if I give an example of this, let's suppose we are saying a dice is rolled. How many outcomes are there in total? Total outcomes are 6. If we roll a fair dice, then how many outcomes are there? There are 6 outcomes in total. 1, 2, 3, 4, 5, 6. So if someone is saying find the probability of getting a number greater than 4, find the probability of getting a number greater than 4, then the event is obtaining a number greater than 4. So out of the total outcomes, how many outcomes are greater than 4? So we know the event that the examiner is talking about has 2 outcomes, because greater than 4 are 2 outcomes, 5 and 6. So the probability of an event obtaining a number greater than 4 would be 2 upon 6. What is 2? The number of outcomes in an event. In this case, the event is obtaining a score greater than 4. The number of outcomes in the event are 2, and the total possible outcomes are 6. The probability gets simplified to 1 upon 3. It's preferred that you leave the answers in fraction form unless otherwise stated, so that the probability remains exact. Right? Everything clear up till now? Just give an acknowledgement on chat so that I can move forward. Right. Let's move forward. Mutually exclusive events, disjoint events. Mutually exclusive events is an important concept that the examiner usually tests, and usually we are being asked to determine whether 2 events are mutually exclusive or not. So before we determine whether the events are mutually exclusive or not, we should be very clear with these words. We should be clear with the meanings of these words. Mutually exclusive events. So what does mutually exclusive actually means? So another name that comes for mutually exclusive events is disjoint events. Have we ever heard about this word before? Yes, we have. When we were covering sets in IGCSE mathematics, the term disjoint sets was being covered. If we can recall, disjoint sets mean nothing in common. Nothing in common. This means intersection of 2 sets is 0. And we have heard about the term null set. So if the 2 sets are disjoint, then A intersection B would be equals to phi, or we write null set. Curly brackets drawn without any element. So disjoint sets mean 2 sets which have nothing in common. Similarly, disjoint events means 2 events which have nothing in common. So mutually exclusive events are those events which have no outcomes common to both. Here comes the definition. 2 events which have no outcomes common to both are called mutually exclusive events. Whenever the examiner asks us to determine whether 2 events are mutually exclusive or not, the thing that we need to see is, are there any common outcomes between A and B? If the, let's suppose examiner asks us, are the events A and B mutually exclusive? So what will we do? We will see if there are any common outcomes between the 2 events or not. So let's suppose one of the events is A and another event is B. So what we need to see is that, are there any common outcomes which are present in event A as well and event B as well? Are there any outcomes? We'll have to see. If there are no common outcomes between A and B, this means the probability of A and B is 0. A and B here means common outcomes. The probability of A and B would mean common outcomes. The probability of common outcomes. So if the probability of common outcomes A and B is 0, This means the events are mutually exclusive. And if the probability of A and B is not zero, means there are two or three outcomes which are common to both, then we will say the events are not mutually exclusive. This is particularly very important, so I repeat. Mutually exclusive events are those events which have no outcomes common to both. So if the examiner asks us to determine whether the events are mutually exclusive or not, what we will see is that, are there any common outcomes between the two events? If there are few outcomes which are common to both, then we will say that probability of A and B is not equal to zero. This means the events are not mutually exclusive. However, if there are no common outcomes and the probability of A and B is zero, we will conclude that the events are mutually exclusive. Let's clarify this further by looking at the two examples below. Another thing is that instead of and, we can also use this sign of intersection. If we can recall, in sets, this was union and this is intersection. Examiner, although sets is not a part of A-level syllabus, but in marking scheme, we usually see this sign. We usually see this intersection sign. Examiner is fond of using this sign. So we should be knowing what this sign actually means. This sign means intersection of two sets or two events. So if we are saying that event A and event B has no common outcomes, so we can write in two ways. We can either say probability of A and B is zero, or we can also write like this: probability of A intersection B is zero. Both are the right ways. If you're perfectly fine with the first one, follow that. Or if you are fine with the second one, you can follow that as well. But you should be aware that examiner is usually writing this in the marking schemes and examiner reports, etc. Now let's move on to the examples to clarify this concept further. Example number 1. A fair dice is thrown. What is the meaning of fair and biased? This is another story. There are so many things to tell. But as for now, fair is an event. A fair dice is a dice in which all outcomes have the same probability. Means 1, 2, 3, 4, 5, 6. Every outcome has same probability, and biased die means few outcomes have higher probability and few outcomes have lesser probability. So this is another thing. I'm not going into the depth as of now. A fair dice is thrown. Event A. Dice shows an odd number. Event B. Dice shows an even number. Determine whether or not the events are mutually exclusive, giving a justification for your answer. This is usually a 2-mark question. So let's solve it. Event A. Dice shows an odd number. So how many outcomes does event A take? Odd outcomes would mean 1, 3, and 5. Event B. Dice shows an even number. Even number would mean 2, 4, or 6. So the outcomes in event A are 1, 3, 5. The outcomes in event B are 2, 4, 6. And we are being asked to determine whether they are mutually exclusive or not. So first, let's try to find the common elements. Are there any common elements between event A and event B? No. In this case, there are no common outcomes. 1, 3, 5, 2, 4, 6 are different outcomes. There are no common outcomes. So whenever there are no common outcomes, the conclusion would be that the events are mutually exclusive. And what will be the justification? So the first thing that we are going to write, the events A and B are mutually exclusive. We have determined that they are mutually exclusive. Now we need to give the justification for our answer. What will the justification be? In this case, the justification would be this: probability of A and B is 0. Or we can also write probability of A intersection B is 0. Because probability of these two events is 0, there are no common outcomes. Because the probability of common outcomes is 0, this means the events are mutually exclusive. Let's move on to the second example. A fair dice is thrown. Event A, dice shows an even number. Event B, the number is greater than 4. Now, outcomes in event A are 2, 4, 6. And outcomes in event B greater than 4 are 5 and 6. Can we see any common elements? Oh yes, there's one element which is common to both. Now we need to determine whether the events are mutually exclusive or not. Over here, the events are not mutually exclusive. Why so? Because in this particular example, there are common outcomes. Means the events are not just disjoint. The events are not mutually exclusive because there are outcomes which are common to both. So we will be writing probability of A and B is equals to 1 upon 6. This is not essential. This is just for your convenience. In this case, probability of A and B, there's one outcome out of the total of 6 outcomes which are common to both. This means the probability of A and B is 1 out of 6. 6 total number of outcomes in the dice, and 1 the common outcomes of event A and B. So the probability of A and B is 1 by 6. So the answer that we will be giving is this: the events are not mutually exclusive. The events are not mutually exclusive. Why? Give a justification for your answer. As probability of A and B is not equal to 0. Above justification was, in example number 1, probability of A and B is 0. And over here, probability of A and B is not equal to 0. So the conclusion is, if the probability of common outcomes is 0, the events are mutually exclusive. If the probability of common outcomes is not 0, the events are not mutually exclusive. I guess I have repeated myself several times. Are you guys clear with this concept? Please acknowledge. Any clarification is required, you are most welcome to ask any question that you have. Right. Keep taking screenshots as well so that you can write the notes. Because if you are going to write notes right now, a lot of time would be consumed in that. Would you want to write? Or is it fine that you take a screenshot and write notes later?
Sir, we'll take screenshots. It's better.
Perfect, Musa. We are moving forward. All right. Let's move on to another example, another important concept, independent events. And after that, we are going to look at a past paper question, which will be covering exclusive events and independent events both. Independent events. Independent events are events which have no effect on one another. As we can see, independent. A child is dependent on his father or his mother. And if we are saying that a child is grown up and now he's independent, this would mean that he is not financially dependent upon anyone. He is on his own. He is independent. Independence, we are already aware of this term, independence. So independent events are those events which have no effect on one another, which are independent of each other. Now there is a lot of details over here, but we are not going to take that into consideration right now because we have limited time. So I'm more exam focused. What is more relevant to us is how will we cater to past paper questions. So whenever we have to solve a question relating to independent events, the equation below is extremely important, and we will be applying this in the past paper questions as well, so that we are able to understand this concept better. So let's start. Independent events by definition would mean events which have no effect on one another. Now from examination point of view, two events A and B are independent if and only if the following equation is satisfied. Two events are independent if and only if the following equation is satisfied. So I've already also written very important because this is the equation that needs to be verified. Now let's read the two lines. The above equation is used to determine whether two events are independent or not. If both sides of this equation are found and both are equal, then the two events are independent. Now these two lines would explain you the entire concept. Look, there are three things. Number one, probability of A and B. Number two, probability of A. And number three, probability of B. Probability of A means probability of event A, probability of event B, and A and B, probability of A and B means probability of common outcomes of A and B. Now, how many outcomes out of the total outcomes are common in A and B? So when we are to prove whether the events are independent or not, we have to find three things. We have to find the probability of common outcomes. We have to find the probability of event A. We have to find the probability of event B. And then we are going to satisfy this equation. If both sides of the equation are equal, like the scenario is like this, 7 upon 11 is equals to 7 upon 11. When we have multiplied A and B, when we have multiplied probability of A and probability of B, we got 7 upon 11. And the probability of common outcomes is also 7 upon 11. So when both sides are equal, so we will say, yes, the events A and B are independent. Why? What will be the justification? Because probability of A and B equals probability of A multiplied by probability of B. Now another instance would be, we are getting 7 upon 11 over here, but 8 over 11 over here. We know that 7 upon 11 is not equals to 8 upon 11. So now we will say, no, the events A and B are not independent. Why? Because probability of A and B is not equal to probability of A multiplied by probability of B. So this is the concept of independent events. The equation that I have written have three things. We have to find all three of them and we have to satisfy this equation. If left hand side of the equation equals right hand side, the events are independent. If they are not equal, the events are not independent. Are we clear up till here? Perfect. Take a screenshot, then we are moving towards the past paper question. All right. Two fair 12-sided dice with sides marked 1, 2, 3, 4, 5, 6 till 12 are thrown. How many dice are there? Two fair 12-sided dice. This is very important. Now few students start thinking, sir, we haven't ever seen a 12-sided dice. Beta, it doesn't matter whether you have seen or not. There is a dice which is 12-sided. So you have to just imagine it, right? And fair, we have already discussed the word fair. Fair means the probability of each outcome is equal. Like if we are talking about the probability of 1, it is 1 upon 12. Probability of 2 is 1 upon 12. Probability of 10 is 1 upon 12. When the probability of each outcome is equal, we are saying that the dice is fair. So there are two dices, 1, 2, 3 till 12, and the numbers on the sides which land face down are noted. Before we solve a particular question, we need to understand it very clearly. Because if we are unable to get a question, we will not be able to solve it. So it is very important that we read the question very carefully and read it multiple times if we are not able to understand it. Right? Two dice are thrown and the numbers on the sides which land face down are noted. So when we throw a dice, it lands on a particular face. So that particular face is noted and the number on that face is noted. Now there are two events that the examiner is talking about. Events Q and events R. Let's discuss event Q. Now here we will have to use our brain and we have to be very alert and our concepts needs to be very clear and we need to think properly before we can answer such types of questions. And of course, the more we practice, the better we get. The event Q is the product of the two numbers is 24. The first dice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And same outcomes for the second dice as well. If someone asks me how many outcomes are there in total, always remember this rule that when we are throwing a dice and there are 12 outcomes in dice 1 and there are 12 outcomes in dice 2, then if we are being asked to find the total number of outcomes, then we multiply 12 by 12. This means total outcomes are 144. If we talk about a 6-sided dice, and if two fair dice are thrown, 6 outcomes of first dice, 6 outcomes of second dice, the total number of outcomes altogether will be 6 multiplied by 6, which means 36. So over here, this is a question of June 2010, paper 6-2, question number 5. Total outcomes are 12 multiplied by 12, that is 144. Right? And now we have to move on to event Q. The product of the two numbers is 24. So which two numbers when multiplied will give us 24? We have to think. Let's start with 1. Can 1 be multiplied by any number? No. 1 cannot be multiplied by any number to give us 24. So I'm writing multiple outcomes over here. Outcome of event A and outcome, wait. This is not A and B, this is dice 1 and 2. Dice 1, dice 2, dice 1, dice 2. So how will we get the product which is 24? If we get a number 2 in dice number 1 and number 12 in dice number 2. This is one possibility. 2 comma 12. Then 3 comes over here and 8 comes over here. 3, 8. Then 4 comes over here. 6 comes over here. 4, 6. Then with 5, there's no possibility. There are no possibilities with 5. Then with 6, when 6 comes over here, here comes 4. So we have to take 6, 4 as well. Then we have to take 8, 3 as well. Then we have to take 12, 2 as well. So remember, 2, 12 and 12, 2 are different. Because 2, 12 means dice 1 shows a 2 and dice 2 shows a 12. Whereas 12, 2 means dice 1 shows a 12 and dice 2 shows a 2. 2, 12 is not the same as 12, 2. So 2, 12, 3, 8, 4, 6, 6, 4, 8, 3, 12, 2. How many outcomes are there altogether? 6 outcomes. These are total of 6 outcomes. So if someone asks us in part number 1, what is the probability of event Q? So two things that we need to know: the number of outcomes in event Q and the total possible outcomes. The total possible outcomes are 144, number of T. We have already found that. And the number of outcomes in event Q are 6. The probability of Q would therefore be 6 upon 144. If you are going to simplify it, the answer would be 1 upon 24. Then comes part number 2, probability of R. We have understood event Q and we have also found the probability of Q. Now the next part is part number 2, probability of event R. So let's understand event R now. What is event R? The description says both of the numbers are greater than 8. Understanding an event is very important. The event R is defined as follows: both of the numbers are greater than 8. So this means we get a score of 9 or more in dice 1. So I'm writing over here dice number 1 and dice number 2. Number 9 can come, number 10 can come, number 11 can come, and number 12 can come. When dice number 1 shows a 9, dice 2 can show a 9, it can show a 10, it can show 11, or it can show a 12. When dice 1 shows a 10, dice 2 can show a 9, it can show a 10, it can show 11, it can also show a 12. When dice 1 shows 11, 11, 9, 11, 10, 11, 11, and 11, 12, then 12, 9, 12, 10, 12, 11, and 12, 12. So with 9, all possible outcomes can come in dice 2. With 10, any possible outcome can come in dice 2. With 11 as well, any outcome can come. With 12 as well, any outcome can come. So how many outcomes are there in total? 9, 9, 9, 10, 9, 11, 9, 12. These are 4 outcomes. 4. Then 10, 9, 10, 11, 10, 12. 4. 4. And 4. The total outcomes are 16. Right? There are a total of 16 outcomes. So if we are talking about probability of event R, then probability of event R would be number of outcomes in event R divided by total possible outcomes. The number of outcomes in event R are 16. The total possible outcomes are 144. If you are going to simplify, the answer that we will get is 1 by 9. So part number 1, the answer was 1 upon 24. Part number 2, the answer is 1 upon 9. All right, Musa, you can ask a question. Yes, beta.
Sir, you know how for dice 2 you did 9, 10, 11, 12? Don't you do the same for dice 1 as well? Like for dice
Actually,
1, it's only a single number, yeah?
yes, I got your point totally.
And-
I could have written like this. Now just I'm answering your question. Dice 1 and dice 2. I could have written like this. Dice 1 can show a 9, 10, 11 or 12. Dice 2 can show a 9, 10, 11 or 12. Now you have to decide how many possibilities are there. With a 9, we can take 9, we can take 10, we can take 11, we can take 12. Now
Yeah.
this is particularly well explained when I draw a possibility diagram. I'm not sure whether you are aware of it or not. Possibility diagram is drawn whenever two events takes place. So for explaining this, just look at this diagram. Dice number 1, dice number 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Then we write over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right?
Yeah.
Now, how many outcomes? Both dice shows a number greater than 9, greater than 8. Dice 1 can show 9, 10, 11, 12. Dice 2 can show 9, 10, 11, 12. Now the outcomes are 9, 9, 9, 10, 9, 11, 9, 12. 10, 9,
Yeah.
10, 10, 10, 11, 10, 12. 11, 9, 11, 10, 11, 11, 11, 12. 12, 9, 12, 10, 12, 11, 12, 12. Musa, can you identify any further outcomes apart from these?
Yeah. Thank you so much. Yeah. Sorry.
You figured that out? You
Makes
understood?
sense. Yeah. Thank you.
Perfect, perfect, perfect. Back to the question. This was just the way of writing that I chose, right? Wait, let me shift that down. Possibility diagram was another thing that was our target, but because this question is covered before, so I have to explain it right now, right? So I have explained possibility diagram. I'll just skim through it again. Right. Back to the question. The probability of R is explained. There are altogether 16 outcomes out of 144. The probability is 16 upon 144 simplified to 1 upon 9. Now part 3 and part number 4. Are events Q and R exclusive? At times, the examiner does not use the word mutually exclusive. The only word that he uses is exclusive. So we should understand that examiner is trying to ask whether the events Q and R are mutually exclusive. And then we have to justify our answer. So let's recall, whenever we are being asked whether the events are mutually exclusive or not, we need to identify as to whether there are any common outcomes or not. If there are common outcomes, the events are not mutually exclusive. And if there are no common outcomes, the events are mutually exclusive. So let's look at in this question, and looking at the common outcomes would also mean the reading the events once again. Just think conceptually. Event Q is The product of the two numbers is 24. We have all the outcomes: 212, 38, 46, 64, 83, 12, 2. Then event R. Both of the numbers are greater than 8. 9, 9, 9, 10, 9, 11, 9, 12, 10, 9, 10, 10, and so on. So are there any outcomes which satisfies both the events together? This means, are there any set of possible numbers which gives us a product of 24 and in which both of the numbers are greater than 8? Are there any outcomes? The answer is no. Because even R says the numbers, both of the numbers are greater than 8. So if both the numbers are greater than 8, the least numbers that can come are 9, 9. So even if you multiply 9, 9, the product would be 81. So it is practically impossible that both the numbers greater than 8 would give us a product of 24. So if we can compare part 1 and part 2, these are all the outcomes in part number 1. These are all the outcomes in part number 2, as I have already explained through a possibility diagram. Just compare. Can you see any common outcomes? Even if we are going to think logically, the answer is no. And if we are going to see and compare the part 1 and part 2 answer, then also we will say no. So this means there are no common outcomes. And when there are no common outcomes, the events will be mutually exclusive. So we'll say yes. The events are mutually exclusive. Why? Give a justification for your answer. The justification is, as probability of Q and R, or we can also write Q intersection R is 0. We have secured full 2 marks. First, for writing a yes or a no. Yes, the events are mutually exclusive. And the second, the justification. Why so? Because the probability of common outcomes is 0. Are we clear with part 3 as well? Then comes part number 4. Are events Q and R independent? Justify your answer. So before we are able to decide whether the events are independent or not, we will not be writing yes or no at the beginning. First, we will be doing our working, and then only can we give a judgment as to whether they're independent or not. So let's look at the equation. The equation that we have understood, that we have read above, the probability of Q and R. I was using A and B. Now because the events are Q and R, I will be redrafting that equation. The probability of Q and R should be equal to probability of Q multiplied by probability of R. So we have to find 3 things. We have to find the probability of Q and R. Then we have to find the probability of Q. Then we have to find the probability of R. And then we are going to substitute the 3 probabilities in this equation. If both the sides of the equation, if both the sides are equal, the events are independent. If both the sides are not equal, the events are not independent. So let's find each one of them. Sir, we have already found that probability of Q and R was found in part number 3. Probability of Q was found in part number 1. Probability of R was found in part number 2. That is why it is just a 2 mark question. Had these been, because these are given, that's why the marks are less. Had these not been given, if all 3 of them were not given and we were to find them, the marks would have been more. So probability of Q and R should equals probability of Q and R. Let's substitute. We have all the probabilities. Probability of Q and R is 0. Probability of Q that we have found in part number 1 is 1 upon 24. Probability of R that we have found in part number 2 is 1 upon 9. Is 0 equals to 1 upon 24 into 1 upon 9? The answer is no. Because if we are going to multiply 1 upon 24 by 1 upon 9, we will get 1 upon 216. And everyone knows that 0 is not equals to 1 upon 216. So we will changing. We'll be writing 0 is not equals to this. This is not equals to this. First we did our working and then we concluded as to whether they are equal or not. Now I'll say the justification has already been given because we have done our working. This is the justification. Probability of Q and R is not equals to probability of Q into probability of R. Initially, I did not write not equal to. Why? Because I was not sure, because I didn't do working. When I did some working and I realized that they are not equal, then I have to cut the equal to sign to show them, to show the examiner that two sides of the equation are not equal. In simple words, left hand side of the equation is not equals to the right hand side. When both sides of the equation are not equal, this means that the events are not independent. Not independent. The events Q and R are not independent. So this is our answer. Are the events Q and R independent? The answer is no. Justification, the entire working that we have done is our justification for the answer. Are we able to understand this question of past papers? All right. Take a screenshot. We can move forward then. Possibility diagram is a simple concept which is already covered. Whenever, just take a screenshot of this. I'll not be investing much time in this. Possibility diagram is made whenever an experiment is repeated twice, whenever something is done twice, whenever two events takes place, whenever an experiment is repeated twice, it shows all the possible outcomes. We have also covered this possibility diagram in IGCSE mathematics. What is the point of bringing in over here, bringing this over here? Because in probability questions, it is particularly useful at few instances to draw a possibility diagram. Now, for that, you need a bit of practice to understand when is it better to use a possibility diagram and when not, and when not. So if you feel that two events are taking place, two experiments are being done, then in that case, it is preferred to draw a possibility diagram. However, at times drawing a possibility diagram just increases our work, and it's better that we work without drawing a possibility diagram. However, at times drawing a possibility diagram ease our tasks, and it is more easier for us to solve the question without drawing a possibility diagram. Example, if we are tossing two coins or tossing the same coin twice, or if we are rolling two dices or rolling the same dice twice. So rolling two different dices or rolling a one dice two times. Surely conditional probability is more important. So let's move on to that. No issues. Conditional probability. A condition is given by the examiner which must be considered before finding the probability of a particular event. The following formula is used. First, let's understand this formula. Probability of A given B is probability of A and B upon probability of B. This is the formula. Examiner says probability of A given B. So what is B? B is the condition that is given by the examiner. B is the condition given. condition given by the examiner. So A oblique B means probability of A given B. Examiner will say probability of A given B. Given, after given, if B is coming, this means after oblique, we will be writing B, and before this oblique, we will be writing A. The formula is probability of A and B comes in the numerator, and probability of B will come in the denominator. Because B is the given condition, the probability of the given condition would come in the denominator, and the probability of common outcomes. We are now well aware of probability of A and B. We also know that we can either write A and B, or we can also write A intersection B. And both of them means probability of common outcomes of A and B. To understand this better, let's look at the example below. Don plays tennis. He plays 2 games. There's a long story short. Don plays tennis and he plays 2 games one after the other. The tree diagram is as follows. Either a description would be given and we will have to draw up tree diagram. Drawing a tree diagram was already a part of our IGCSE, so you must be aware of that. We can explain that, but that would just require some more time, so I'm not going into that detail. The tree diagram is as follows. The probability of winning, what does W means? Probability of winning. L would mean probability of losing. So if Don plays the first game, the probability of winning is 0.7. So automatically the probability of losing would be 0.3, because the total probability equals 1. If winning is 0.7, losing would be 1 minus 0.7. If Don wins the first game, the probability of winning the second game is 0.8, and of losing the second game is 0.2. If Don loses the first game, the probability of winning the second game is 0.6 and of losing is 0.4. Find the probability that Don wins the first game given that he loses the second game. Now the condition that comes after the word given that is the given condition. Given that he loses the second game. So this is the condition given. So will this word given that always be used? No. In few questions, examiner uses this word given that, and in few he does not use. So it just depends upon the number of questions that you practice before going inside an examination, so that you are pretty much sure as to what actually is the meaning of given that. Like, even if given that is not used, the examiner would have asked like this: find the probability that Don wins the first game. No, examiner would have written like this: Don loses the second game. Find the probability that he wins the first game. Now the both scenarios are same. The way of writing is different. Find the probability that Don wins the first game given that he loses the second game. And over here, the question starts with the condition. This is again the given condition. So we need to pick that this is what comes after given that. So find the probability. Finding the probability that he wins the first game, and examiner is telling Don loses the second game. Both are the same types of questions, same working needs to be done. It's just the way of writing that is different. So now let's solve it. Probability, find the probability that he wins the first game, that Don wins the first game. Probability that Don wins first game given that he loses second game. So let's apply the formula. Probability of the common outcome would come above. Winning first and lose second. The common part would come above, and the condition that comes after the oblique sign, loses second game, would come below. Probability of winning first and losing second. Winning first and losing second. Can we find the probability of winning first and losing second? Yes. With the help of a tree diagram, we can do that. Winning first, losing second. So it is 0.7. Wait, let me write like this. WL. Then probability of losing second. Now learn to apply the given condition. Probability of losing second means the Don has lost the second game. Lost the second game. There are two possibilities. Losing the second game doesn't specify the first one as to whether Don has won the first game or lost the second game is not specified. We have to find the probability of winning first and losing second. So WL is the outcome that will come in the numerator. But for the denominator, the condition is losing second. So losing second combines two outcomes. Losing second after losing the first, or losing second after winning the first. So all possible outcomes comes in the denominator. Always remember, all possible outcomes. And in the numerator comes the find the probability. So if we have to find the probability of winning first and losing second, it will come in the numerator. And all possible outcomes as per the given condition. As per given condition will come in the denominator. So winning first, losing second in the numerator, and losing second, which would mean winning losing and losing will come in the denominator. Also, it's useful to remember that whatever outcomes comes in the denominator, few of those outcomes comes in the numerator. Something really important that I'm telling, and with this will be polished the more questions you practice. All possible outcomes come in the denominator, and out of those outcomes, few would come in the numerator. So in the denominator comes more outcomes, and out of those many outcomes, few would come in the numerator, and which outcomes will come in the numerator would depend upon what the question is being asked. Find the probability that Don wins the first game. So winning, losing will come in the numerator, and all the possible outcomes which ends with losing the second game will come in the denominator. So losing second would mean losing first and then losing second, winning first and then losing second, winning, losing, losing, winning, losing would come in the numerator. Winning, losing is 0.7 into 0.2, then winning, losing 0.7 into 0.2, losing 0.3 into 0.4. So if we are going to find it and we are going to divide it, we will definitely be getting an answer in our calculators. Here we have ended the concept of conditional probability. The answer is 7 upon 30. There's so many things that I need to tell, but of course the time is limited. Everything cannot be told. But we have, alhamdulillah, covered many important areas of probability in today's class. Right? And always remember, the more we practice, the better we get. There are a lot of past papers. I have a lot of past paper questions. Lot of past papers. I have around 48 past papers questions that are being compiled. There are a lot of questions. We cannot solve every question, but we should try that we solve as many as possible.
Sir,
Yes, Musa.
is this it for probability or is there more?
I planned something other than this as well, but this can be covered later on. As for now, this is it for probability.
So after dependent events, we're done with probability.
Yes, after dependent events, we'll be done with probability concepts. Then any session that you would be needing for past papers, you can. I can send the past paper file. There are a lot of questions you people can solve independently. And then if you are willing to get any question solved in the live class, you can just let me know the question numbers, and then we can solve those particular questions in that class.
Okay, sir. Thank you so much. Take care.
Most
Bye.
most welcome. Take care. Allah Hafiz.